So here we're expanding our study of solving systems of equations to systems that have three variables in them and therefore three equations rather than just two equations with two variables. And so for these types of systems, we're going to use elimination as our primary tool for solving. So for two variable systems, we can use either substitution or elimination depending on the circumstances, but really it's going to be a series of elimination steps that we're going to deploy when we're solving a three variable system. And so really what we need to do is we need to take a look at all three equations and all three variables and figure out which variable is going to be the easiest one to get rid of twice. Because what we're going to do is we're going to take these three equations and three variables and we're first going to knock them down so that there's two equations with only two variables in them. So that might be x and y, that might be y and z, that might be x and z. So that means we're going to have to combine two equations to get rid of one of the variables and then combine a different pairing of two equations to get rid of that same variable. So we want to try to choose wisely to keep things as simple for us as we can. Once we've done that, so that's steps 1 and steps 2 taken together, then we're going to have this system of two equations and two variables. So now we're going to rely on either substitution or perhaps another elimination, round of elimination to eliminate one of those two variables. And then that's going to give us a pathway to solving for the last variable that's remaining. And then we just work backwards by plugging in, like we do in a two variable system, to figure out the values of the other two. So it's worth it to keep this slide in front of you as we're going to progress through the examples, including this first one here. So this is the same example. I've just put it on the second slide here so we've got space to work. And so, as I said, the first thing we've got to do is determine which variable is going to be the easiest one to eliminate twice. And so I would make the case that y is that variable. If we look at the top two equations, we can just add those equations without having to multiply one of them or the other to get a match on the y's. If we just add those equations, we're going to get the y's to disappear and be left with just x and z. And then likewise, if I add the bottom two equations, I've got a positive y and a negative y in each of those, so that too is going to eliminate the y, leaving me with an equation that has just x and z in it. So that's going to be my approach that I'm going to take. So I'm going to add together, I'm going to move over here equations 1 and 2, the first two equations here. So I'm just going to recopy them. So I've got 2x minus y plus 2z equals 15. And then I've got negative x plus y plus z equals 3. And so like I said, I'm going to add those equations together because doing that, I'm going to get those y's to cancel out. And then I've got 2x plus negative x, just have to be careful with our positive negative sign, so we get just x. And then I've got 2z plus z gives me 3z. And then I've got 15 plus 3 gives me 18. And so then I'm going to do the exact same thing. I'm going to add together the bottom two equations. So when I add those bottom two equations, I'll go ahead and do that in blue, I'm going to get the same result. I'm going to get the y's to cancel out, and it's just going to be the x's and z's that are left. So I've got negative x plus y plus z equals 3, and then I've got 3x minus y plus 2z equals 18. And so if I add these equations, once again I get the y's to disappear. I'm going to get negative x plus 3x gives me 2x. And then I've got z plus 2z gives me 3z equals 3 plus 18 is 21. And so now I've got these two equations that no longer have y in them. They just have x and z. So I'm going to bring these over here, and I'm going to recopy them stacked above each other. So x plus 3z equals 18, and then 2x plus 3z equals 21. And now I need to look to see how can I get rid of one of these two variables. Well, I could look at this x right here and say it'd be pretty easy to isolate, so I could use substitution. But even easier, I have a match on the coefficients in front of the z's. I've got 3 in front of each of those. So this time I can go ahead and subtract these two equations, and that'll get the z's to disappear, leaving me with just x. So I've got x minus 2x, so that equals negative x. I've got 18 minus 21, which gives me negative 3. And so then if we hopefully remember that that's like having a negative 1 in front of the x, my last step here is going to be to divide both sides by negative 1. And so now I've got x equals negative 3 divided by negative 1, which is 3. And so I'm not quite done yet, but the pathway is clear here. I've got one of my two variable values. I now need to plug that into some of the equations that I have in front of me to figure out the others. So I'm not going to go back to the originals yet. I have to use one of these two first, because now that I have x, I need to plug it in someplace where I only have one other variable so that I can get z. So if we use this, I'll switch to black here. If I use this equation here, I'm going to have x plus 3z equals 18. So I'm going to replace the x, probably could have done that right away, with 3. Whoops. So let's try that again. So I'm going to have 3 plus 3z equals 18. So I'm going to subtract 3 from both sides. I now have 3z equals 15. If I divide both sides by 3, I get z equals 5. So now I've got two of the three variable values. And so now I'm ready to go back to one of the original equations, plug in x as 3, plug in z as 5, and then I can solve for y. So if we can pick any one of the three, I'm going to go ahead and pick the top one just out of convenience. So we're going to have 2x, so 2 times 3, minus y, plus 2 times z, so 2 times 5, equals 15. So 2 times 3 is 6, minus y, plus 10, equals 15. I'm going to gather my like terms on this side, so 6 plus 10 gives me 16 minus y equals 15. I can subtract 16 from both sides, so I get negative y equals 15 minus 16 is negative 1, or if I scroll down just a touch, divide both sides by negative 1, and I get y equals positive 1. And so then taken together, that is the solution. That is the only ordered triple, not an ordered pair, since there's three numbers, it's an ordered triple. It's the only ordered triple that works in all three of those equations. And so we could write it either listing them all off, usually in alphabetical order, or we can go 3, 1, 5 for x, y, z order, and there's our solution.